Hello everybody, welcome back to class. Man, what a long weekend. I had so much work to do. It feels like it's been weeks since I actually taught a lecture. We just had our midterm for Computer Science 3200 this morning, so I wasn't giving a lecture there. It's weird to start the day with this class. So, let's see where we are in the course. It is today, October 20th, and we are going to be spending the entire lecture talking about Assignment 3. So I'm not sure if we're going to spend the whole hour and 20 minutes on it, but we'll get the whole assignment explained. And it's probably the most involved assignment overall in terms of biggest jump from one assignment to the next, so we do want to spend a good bit of time talking about the assignment. So this assignment, if we look back at the lectures that we covered since Assignment 2, oh, and just as a reminder, Assignment 2 is due tonight, so make sure you get that in. We covered collision detection and resolution for axis-aligned bounding boxes, so there'll be lots of rectangle collisions in this assignment. We covered sprites, textures, and animations, so this assignment we'll be using all of those things. And we also cover like actions, to a lesser extent, how you would implement replays. There's no replays in this assignment, however. You'll be doing that in the project. And components, so we talked about how components are stored now in entities rather than just variables of shared pointers. They're stored in tuples, which we can use get component and add component, etc. So all of these things will be in Assignment 3. So let's first have a look at Assignment 3. So here is Mega Mario. Or not Mario, or whatever you want to say to avoid copyright infringement, right? So we may or may not have borrowed some assets for this assignment. How's the microphone volume out there for people, by the way? Just want to make sure that the levels are okay before I get into everything. Perfect, thanks. I don't want to like record an hour and then realize that I didn't have my voice working properly. So here we've got, first of all, we've got a menu system. So that's something else that we're doing. But the menu system is kind of done for you. But now we've got multiple scenes as well. So here we have a scene that's a menu scene. And in this menu scene, the W key and the S key move you up and down. And then you can escape. So if you press escape, you quit the game. Or if you press D, you actually play the game with that level. Oh, sorry, this is not the solution code, this is the student code. So let me pull up the solution code real quick. All right, so this is the solution code. So this is the game that we will be making in this course. So I'm going to briefly go over like a visual inspection of the game. And then I will, let me just make this darker a bit. So I'll go over a visual sort of playing the game, and then I'll do what I always do and go over the Readme file and give in very, very great detail exactly what you have to do for this game. So here we have Mega Man running around inside a Mario level. And as you can see, now we have textures. So we have bricks, we have hills in the background, we have question marks, we have pipes, and we are interacting with all of these things in very specific ways, which I'll get into a bit later. You can see that Mega Man is animated, so he is running. Mega Man can move left, Mega Man can move right, and when he moves left, he's facing left. When he moves right, he's facing right. He can jump, and when he jumps, the animation changes, and when he lands, the animation changes. So currently in the standing animation, now I'm in the running animation, now I'm in the jumping animation, okay? When you press the jump key, you can let go to time the height of your jump. All right, so you can jump to a maximum height, or you can let go partway through, excuse me, to vary the height of your jump. Now, as you can see, there's gravity in the game. So as you fall, you get pulled towards the bottom of the screen, and if you land on something, then you land on it. Certain things you do interact with, so these tiles you do interact with, but the things like the clouds in this bush you don't interact with, and so we'll explain a bit later how that exactly happens. Now, you can see here that if I'm interacting with these tiles from the top, nothing happens except I land on them. But if I interact from the bottom, something else happens. So I can hit this brick to kill it, or I can hit this coin to make or this question mark to make a coin animation appear. And when I do that, I can no longer hit this question mark. Mega Man can also shoot. So he shoots the Buster right here. Doesn't have a shoot animation. I forgot to put that in. So we won't be doing that for this assignment. If I shoot a brick, it will be destroyed. If I shoot anything else, it won't be destroyed. These pipes don't do anything right now, other than you can interact with them and walk on them. If I keep going here in the level, there's a little bit of interesting gameplay here. So we've got to keep going to the right to finish the level. So I could do that by jumping up here or taking the easy route. So here I can jump. I have to jump over here, keep going, and then I will finish the level by touching any part of the flagpole, and then it will reset back to the level. So those are all the mechanics that you have to implement for this assignment. And it may seem a little bit easy, but there's quite a bit of stuff going on here. And in order to help you along with the assignment, what I've also done, if I can just run this again real quick, is I've included some debug drawing options. So for example, if I hit the T button, that will toggle the drawing of the textures on and off. These debug options are implemented for you when I give you the assignment. So hitting the T button will toggle the textures on and off. Hitting the C button will toggle the collision boxes on and off. Now that's a bit hard to see until I turn off the textures. And so with the collision box drawing on, you actually get to see what the physics engine is seeing in the game. Okay? So this is sort of the debug view that you can get really precise. Like, for example, if I have textures drawn on here, it looks like Mega Man is not quite touching the pipe, but with the textures turned off, you can see why that is, and that's because the collision boxes are indeed touching. Here you can see that when I hit a brick, its collision box gets destroyed right away so that we can jump through the explosion. So if I show you that here, while the explosion is happening, I can jump through the explosion, all right? And as you can see as well, the bush and the clouds have no collision box, and so that's why I'm not colliding with them. Also, one other thing that I do is I have a grid structure, and when you press the G key, it will draw the grid coordinates for you. And we'll get into this once we start talking about the level file and the config, but there's a grid system in which the level is defined, and so these levels are defined in configuration files, and we'll be loading them in at the grid resolution. And so if I say, for example, that this question mark block should go at position 6-3, that means that the bottom left of this question mark box should be aligned with the bottom left of the grid 6-3. Similarly, over here, when I say I want this bush animation to be at position 0-1, it means that the bottom left of the texture of that bush animation has to be aligned with the bottom left of the cell 0-1. So this is going to be probably the most semi-confusing thing about the assignment, is that, so SFML, as before, it still draws from 0-0 in the top left, but when I define the level files, 0-0 is in the bottom left. So you just have to write one function which takes in the coordinate of the grid and returns the coordinate of the drawing, okay? And similarly, because the sprite positions will be defined at the pixel level, so they'll be in the SFML coordinate system, then when I'm moving upwards, so when I jump, Mega Man's Y velocity will actually be negative because Y is decreasing. And when gravity is affecting it, when Mega Man is being pulled downwards, the Y velocity will actually be positive because Y is decreasing or increasing as you go downward. Similarly, if Mega Man is on top of another sprite, then Mega Man's Y value is going to be less than that sprite. And if this sprite is below Mega Man, it means that this Y value is greater than that. So that's just one little thing to wrap your head around. It's just that the level file, in order to make it a little bit more intuitive for you, I've made it so that the grid system starts from 0 at the bottom, okay? And so that way it'll be a little bit easier when you go to create your own level. Okay, and anytime you have any questions, by the way, feel free to say them in the chat. This is a pretty chill stream. There's no lecture going on, so I do have time to stop and answer questions. Okie doke. So let's get over to the Readme file. And I will read through all of this to make sure that I haven't made any mistakes, but if I have made mistakes, then I'll correct them live, and that way I won't get a bunch of questions about them. So, assignment 3. Submission. For this assignment, you will zip and submit the entire source directory folder of the assignment. So this is similar to assignment 2. You are not allowed to add any files in addition to the ones already in the source folder from the assignment zip file. This means that you will not be submitting any changes you have made to the Visual Studio project if you used it for development. Now, that being said, if you really want to, so for bonus marks in this assignment, you can get up to 10% bonus marks, which are completely subjective by me, for including bonus functionality. And if you have to include other files for that, don't make any additional source files, but if you really want to include another asset or something, you can. You just have to include that in the zip file and give us directions in how to set it up. So you must include the following in a comment at the top of main CPP. So this is all the students' names, their CS usernames, and their student numbers. And if you didn't get a specific feature to work, please explain what you tried to do to get it work, and partial marks will be given for effort. So this assignment will take a little while, and so you have a full 3 weeks to do this assignment. You have a long time to do this assignment, but please start it this week so that if you're having trouble with something, you can ask me questions. Because again, if you have 3 weeks to do something and you come to me the day before it's due, and you got really basic questions about how to start the assignment, then that's when I'm not so sympathetic. So please start it early. All right, program specification. So in this assignment, you will be writing the game that is presented in class, the one I just showed you. The game must have the following features. All right, so this time we have an additional thing, which are assets. So entities in the game will be rendered using various textures and animations, which we will be calling assets. And in this game, we have fonts as well. So we don't have sound in this game, but we do have sound in the next game. So assignment 4 will have sound. Assets are loaded at once at the beginning of the program and stored in the asset class, which is stored by the game engine class. So all assets are defined in assets.txt with the syntax defined below. And I'll get to the syntax of the assets file, but let's just have a look at that real quick. So here's the assets configuration file, and it's a pretty simple syntax. So there's 3 different things that we can currently define in the assets file. There's textures. So for example here, the syntax is texture. So this is saying this line represents a texture. Here we have texture air, and then we have a file name that includes no spaces in the name, representing the PNG image, which is our texture file. So this means that the texture air is living at this image file, and that's a texture. We can also define animations, and animations are given in a similar way, but I'll get to that syntax later because there's a few parameters here, and I'll talk about that later. And then we have fonts as well. Okay, so that's the animations file, and basically any animation or texture or font that we want to use in our program has to be present in this assets file. And I'll come back to the assets file once we get to it. Okie dokie. All right. Note: all entity positions in this assignment denote the center of their rectangular sprite. It also denotes the center of the bounding box. If it has one, it also denotes the center of the bounding box if it has one. Okay, so if it has a bounding box, we're looking at the center. So this is set via the sprite.setOrigin function in the animation class constructor. So I want to show you what this means. So where are we going here? To the Blackboard. Okay, so here I've shown, so the set origin function, by default, if you're drawing a rectangular sprite in SFML, the position is right here in the top left corner. So the position of the sprite will be the top left corner. However, if we take that sprite and we can use the set origin function, and we can move this origin down to the middle of the rectangle. And what that means is whenever you set the position of your sprite, you will be setting it to the middle. And the thing that does for us in this assignment is that we want the sprite and the bounding box to potentially have different bounds, but we want them both to be centered about the middle of the position. Okay, so that's why the middle of the sprite is what we're using as the position. And so here we have an example where all we have to do in order to do this, and this is already done for you, I just want to explain it, is that we set the origin of the sprite to the width over 2 and height over 2. And that way we move the origin right here. So that tells the SFML that when we draw this, we're drawing it with respect to the middle of the sprite. Also, if we use the rotate function in SFML, it rotates about the origin. So for example here, let me give one more example. If we had an object like this, and we had its origin up here, so we didn't set origin, and we rotated it, it would rotate about that origin. So it would look like this. But here, if we rotate an object around the center after we've set origin, then we would get kind of the behavior that we wanted, right? So it does have more effects on it, but we probably won't be using rotate unless you're using that for a bonus objective. So this is what that set origin functionality does. Okay, let's go back. So let's talk about the player. So again, the player is the Mega Man sprite, and I know that there's a lot of text in this file, but there's a lot of things going on, right? The game only takes about 5 minutes to explain when you're playing it, but actually talking about what you have to implement, there's a lot of stuff going on. That's why you have 3 weeks. So the player entity in the game is represented by Mega Man, which has several different animations: stand, run, and air. You must determine which state the player is currently in and assign the correct animation. The player moves with the following controls. So left is A, right is D, jump is W, and shoot is space. So there's only 4 controls right now by default in the program. If you want more controls as a bonus, so for example, one bonus that some people did was implementing like the sliding functionality, like in later Mega Man games. That was pretty cool, or the dash. The player can move left, move right, or shoot at any time during the game. That means that the player can move left or right while they're in the air. So that means that, for example, if I'm playing and I jump, I can move left and right while I'm in the air. So I can jump to the right and then come back to the left in midair. Okay? Also, I can shoot in midair. Now, where was I? The player can only jump if it is currently standing on a tile. So what that means is there's no double jumping, right? So you can't just keep hitting the W key and keep jumping upwards. You can only jump when you press the button and you're standing on a tile. If the jump key is held, meaning that you press it and you don't release it, the player should not continuously jump, but instead it should only jump once per button press. If the player lets go of the jump key mid-jump, it should start falling back down immediately. So this behavior means that if I press and hold the W key here, I jump once, but I don't keep jumping. Okay, so I have to have some mechanism that says, for example, if you've detected that you've landed back on a tile, then now you can jump again. Similarly, if I press it, you can see here, this is a full jump height. So let me try and place the mouse cursor at the full jump height. So it's about right here. But I can also press the key quickly and release it to vary my jump height. So you have to implement that as well. Okay. Next one. If the player moves left or right, the player's sprite will face in that direction until the other direction has been pressed. And what that means is that if I press the left key, Mega Man is facing to the left. And if I press the right key, Mega Man is facing to the right. Now you might say, oh, maybe we have to have like 2 sprites in that case, right? We have to have all of our animations for when it's moving to the right and all of our animations for moving to the left. But it turns out that's not the case. And I think I have this later in the notes or maybe in the code. But essentially, if you set the player's X scale, so if you set the sprite's scale, so you can say sprite.setScale, if you change the X component to -1, it will, instead of making it bigger or smaller, it'll just flip it in the X-axis. So if the scale is -1, Mega Man is facing to the left. If the scale is 1, then it's facing to the right. So that's a really easy way to implement that. So bullets shot by the player should travel in the direction that the player is facing. So here if I press shoot, I'm shooting to the right. If I turn to the left and I shoot, the bullets go to the left. Next, the player collides with tile entities in the level. See the level syntax. And I'll talk about that later. And cannot move through them. The player lands on a tile entity and stands in place if it falls on it from above. So my grammar there is bad, but essentially you can't move through anything that is specified as a tile, okay? You may be able to jump below it and do some interesting things, but you can't move through it. Like this. And if you fall from above and land on it, then what happens is you land on it and you can't go any further. And if you collide with it from below, then you immediately start falling back down, okay? So one of the things you may run into when you first start the assignment is that when you first detect these collisions, you may hover in place. But what you have to do is actually set the Y velocity back to 0 so that it keeps going downward. So you don't jump up and you're like hovering on the ceiling and then slowly come back down. The player does not collide with deck entities in the level. So these tiles here, they're specified via tile in the level, and I'll show that in a minute. And the things that we can't collide with are specified as deck. So these are tiles, these question marks, and these bushes and these clouds are specified as deck or decorations. And the rule is deck are given no collisions, collision box, and tiles are given collision boxes. If the player falls below a Y position of 0, oh, this is a mistake, okay? Let me say if the player falls below the bottom of the screen, they respawn at the start. So let me go through and show that. So Y position of 0 is not correct because a Y position of 0 is actually up at the top. So if I fall down this hole, I respawn at the beginning of the level. Okay, so you've got to detect that as well. Where are we now? So the player should have a gravity component which constantly accelerates it downward on the screen until it collides with a tile. So essentially, acceleration. So before we only had velocity. So velocity, the magnitude of the velocity is our speed. What we did in order to update our position was to take our position and add the velocity to the position. But now we have acceleration, which is the second derivative if you know any physics. And so the way we update our velocity is by adding our acceleration to our velocity, and then we add our velocity to our position. So it's just 2 lines of code there. So the player has a maximum speed specified in the level file, which it should not exceed in either the X or Y direction. And what that maximum speed essentially says is that if we fall from a great enough height, we don't want it to be able to go infinitely fast, so it could say pass through the bottom ground here. So there's a maximum speed that you have to cap, all of your movements at. The player will be given a bounding box of a size specified in the level file. I'll show that when we get to the level file. And the player's sprite and bounding box are centered on the player's position. So again, the position of each tile, the position of each entity is given by the center of the entity. Okay, so that's the player specification. Now let's talk about animations. We showed last time what the animation class looks like and how we set that up. So here's what you have to do with animations. I've done a lot of it for you, but some of it you do have to do. So the animation asset specification, we'll talk about that when we get to the config session. The config file part of the explanation. So animations are implemented by storing multiple frames inside a texture. The animation class handles frame advancement based on the animation speed. We talked about that last time. You need to implement the animation update function to properly progress animations. And I'll show that once we get to it. Actually, let me just show it now. So here's the animation class. We talked about this last time. Here are the variables that we talked about last time. And over here in the animation class, you need to implement the update function using the code that we looked at last time in class. Okay, so wherever there's a to-do, if you want to know if you've implemented everything in the assignment or not, essentially do a Control F and look for to-do, and any function that you have to implement will have a to-do next to it. So you have to implement this animation function, or sorry, the animation update function. You also need to implement the animation has ended function, which returns true if an animation has finished its last frame, false otherwise. So down at the bottom here, there's a has ended function, and you have to detect whether or not the animation has finished animating to the last frame. Animations can either be repeating, loop forever, or non-repeating, play once. So for example, if I rerun this, so Mega Man's running animation loops forever, okay? Technically, all of these brick animations, you can see here the question mark animation. It might be a little hard over the stream, but this is actually fluctuating between 2 different or 3 different frames of animation. It's getting a little darker, then brighter again. So that's a looping animation. Mega Man's run is a looping animation. Even this pipe is actually given by an animation. The animation just has 1 frame. But there are certain things in the assignment that have non-looping animations. So for example, the explosion animation is not looping. Okay? So once the explosion animation finishes, you have to detect that and destroy the entity that contains that animation. So any animation with a non-repeating animation should be destroyed once its animations has ended returns true. So once it's finished 1 cycle, you have to destroy the entity whose animation has finished. Excuse me. Decoration entities. So decoration entities, or decks in the level file, are simply drawn to the screen and don't interact with any entities in the game in any way. Okay, so those decks are the clouds and the bushes. Decorations can be given any animation in the game, but intuitively they should be reserved for things like clouds and bushes, etc. In the next assignment, we'll actually see some clever uses of decorations, but for now, that's all that they do. Okay, now we'll talk about the tile specification. So tiles are entities that define the level geometry and interact with the players. Tiles can be given any animation that is defined in the assets file. All tiles will be given a bounding box equal to the size of the animation of that tile. So you can get the size of the animation by calling this. So we have tile get component c animation dot get size. So we can get the size of the animation by doing this. The current animation displayed for a tile can be retrieved with this. So if we want to get the name of the animation, for example, brick or question mark or run or stand or pipe or whatever, we can get it via this function. Tiles have different behavior depending on which animation that they are given. And so there's 2 specific examples here. If it's not a brick or it's not a question mark, all that happens is that you can't move through it. Okay, there's only 2 other examples, which are bricks and question tiles. So brick tiles are given the brick animation. When a brick tile collides with a bullet or is hit by a player from below, a couple of things happen. So its animation should change to explosion, non-repeating. So you have to look up the animation and change it. Non-repeating animation entities are destroyed when has ended is true. and its bounding box component should be removed. So what does that mean? Well, it means that when I hit this brick from below, its animation should change from brick to explosion. When the explosion has finished, the entity will be destroyed. But in the meantime, we also remove its bounding box entity so that I can jump through the explosion. Okay, so just watch. I'll hit this, the explosion is playing, and I can jump through that explosion. See how that works? Hit it, jump through the explosion. Hit it, jump through the explosion. If I run it again, and I look at it from the wireframe point of view, if I hit it, there's no bounding box that gets created once it's destroyed. Okay, so once I hit it, its bounding box is removed. Okay, so that's what that means. Question tiles are given the question animation when created. When a question tile is hit by the player from below, two things happen. So its animation is going to change to the darker question 2 animation, and a temporary lifespan entity with the coin animation should appear for, 30 frames, 64 pixels above the location of the question entity. So our grid system that we use for the level uses a grid size of 64 by 64 pixels. So what I mean by that is when I hit this question mark from below, two things are going to happen. Its animation is going to change to question 2, which is a darker one, and it should spawn a coin one tile above, or one grid cell above, that appears for 30 frames, or if it's 60 frames a second, half a second, and then is destroyed. Okay, so we give that coin a lifespan of 30 frames, and our lifespan system should handle that for us. And of course, once the animation is changed to question 2, then it's no longer equal to question, and so if we hit this one, then we don't get the coin appearing, right? So we get that behavior for free. All right, so drawing. All of the rendering has been implemented for you. You don't need to do anything. As soon as you're done the level reading stuff, then all of it will be drawn for you. So that's really easy. Bonus. Any special effects which do not alter gameplay can be added for up to 5% bonus marks on the assignment. Note that assignments cannot go above 100% total marks, but the 5% bonus can overwrite any marks lost in other areas of the assignment. I don't know why I had this in there. That was for... Yeah, why not? I'll leave that in there. You can put in a special weapon in this one too. Why not? And if you do some bonus stuff, I will show off the cooler bonus submissions in the class during the stream. So some miscellaneous stuff. So the P key should pause the game. Do I have that implemented yet? Let me just see. So if I jump and pause, yeah, it's paused. Okay. If I pause when a bullet is in the air and then unpause, it should keep going. If I pause when there's an animation playing like this coin and then unpause, it should keep going for the 30 frames, okay? If I pause during an explosion, then that should be paused correctly and then keep going. And so pausing should affect the game in that way. Pressing the R key toggles the drawing of textures. Actually, this is T. Pressing the C key toggles the drawing of the bounding boxes of entities. And pressing the G key toggles the grid, and I can see the grid right here. Okay, so as you move forward, you can see the grid. And it might be hard to see on the stream, but it actually does print out the X and Y locations for you. Okay, level creation. For this assignment, you are also required to create your own level. This level should include some interesting gameplay. Include this level in the zip file as level.txt, and I will show off some of the more interesting levels in class after the assignment is due. So here, for example, if I load the solution, this is level 1. If I go back and I load level 2 is just defined as a few bricks here, and if I fall off, I go back to the start. And if you look at the grid, then these are the locations where these grids, ground tiles are placed. Config files. Of course we have config files. We love data-oriented design. So there will be two configuration files in the assignment, the assets config file and the level config file. So let's look at the assets config file. There will be 3 different line types in the assets file, each of which correspond to a different type of asset. They are as follows. So we looked at the texture asset before. So the line will say texture NP. So texture, where are we? Yeah. So texture, name of the texture, that's N, and P is the file path of the texture. Okay, so that's easy, that's the texture. The animation is a little more complicated. So animation will have N, T, F, and S. So the animation name is N. So the texture name is T, the frame count is F, and the animation speed is S. So the frame count is the number of frames in the animation. So that's the number of total textures that define the animation. And S is the number of game frames between the animation frames. So what do I mean by that? Well, let's go look over at the assets file and we'll look at an animation. So for example, running. If I go over to images, Mega Man Run 64. Okay. So here is the Mega Man run animation. This is how it's specified. And we looked at this last time, right? So tech run, this is, if we look up here, when we defined the texture, tech run, we said it was images/megaman/run64.png. So this is run64.png, the file that we currently have open. Let me move this up here so I can have both on the screen. Okay, so I first have to define the texture, and then I have to define the animation. And the reason for that is because the texture name, so tech run, is how we refer to the texture for the animation. So here my animation run is going to use the tech run texture. It has 4 frames of animation, and I'm going to have 10 game frames between the switching of the frames of the animation. So if I go back and I run the solution again, if I have 10 here, this means that 6 times per second the animation is changing, okay? If I change this to 60, then when I rerun the assignment, it should be that when Mega Man is running, the animation changes once per second, and you can see that that's true. Okay, so that's what that second animation means, or that second parameter means, is how many game frames between the switching of the animation frames. If I come back in here and do something like this, so if I change this 4 to 2, well, that's going to mess everything up. And it's actually going to think now that the first 2 animations are actually 1 frame. And so if I actually draw this, you get weird stuff happening, okay? So make sure that you put the correct number of frames, and if these numbers are actually co-prime, you can get some really weird effects. So let's go in here and look at this. So you get all sorts of crazy stuff happening based on the math that you put in there. So make sure that you have the correct thing happening. Let me just see if it happens. If I have 1, I think it will actually play the whole animation. Yeah. So make sure that that number is correct when you do that. Let's see what happens if I put in 10 here. I'm just playing around with it now. Maybe we'll even crash. Yeah, so you get really weird stuff happening. So make sure that this is set correctly, and then your animations will be playing correctly. Cool. And all the math associated with that we covered in the last lecture. Then we have the font asset specification, and this is the same as assignment 2, so you really don't have to touch that. The really different thing about this assignment is the level specification file. So now that we're done with assets, let me bring up the level spec file. So game levels will be specified by a level file, which contains a list of entity specifications, 1 per line. It will also contain a single line which specifies the property of the player in that level. In this way, you can define an entire level in the data file rather than programming it into code. The syntax of the lines of a level file are as follows. And I'll get to that. But let's just look at the level file first. So here's the level file for level 1. The syntax is really, really simple. So I'll open up this, and then I'll open up the assignment as well. And let's just open up here. So again, as I said, The level file, let's just see. Oh, please don't break on me. I have no idea what this looks like on your screen. Are you seeing a magnified version? I can't actually see it. Please say in the chat if you see this magnified. Okay. So, here you can see 0, 0, and this is a ground brick. So it means that the ground brick's bottom left-hand side of the texture should be aligned at 0, 0. Similarly, this bush decoration, the bottom left of that bush decoration should be aligned with tile 0, 1's bottom left. Okay, so that's how we're specifying our tiles. Let me see if I can get out of here. Okay, I had no idea if that worked or not, so I apologize. So if you didn't know, you can hold the Windows key and press the plus button a bunch of times to zoom in Windows 10. But when you do, and you have multiple monitors, it actually zooms in and stretches it among all your monitors. So it actually covered up my OBS monitor, so I couldn't see what was going on. Okay, so if you look here, we have tile ground 0, 0. So down here at 0, 0, we have a ground tile. We also have tile ground 1, 0, 2, 0. So all the way along the ground here, all the way up to like 20, 0 or something, we have ground tiles that are specified. We also have a bush big decoration, which is at tile 0, 1. So again, this means that we should be drawing the bush big decoration meaning we can't interact with it in any way, and the bottom left of that tile should be perfectly positioned at the bottom left of grid cell 0, 1. Okay? So, and remember, and I'll get into this when I look at the code, that when you read that in, you have to look at the size of the bush big animation and calculate the center, which is so we're storing the entity positions by their centers. So you have to calculate the center position correctly such that the bottom left-hand side correctly aligns itself with the bottom left of here. And that's really not hard. All you have to do is subtract half the width and the height, and that's it. Okay, now let's look at something a little more interesting where we have, let's see where we show these bricks and question marks. So if you can see here, we have a brick at position 5, 3. So let's look over here where I did that, and why can't I find it easily? Okay, so we have tile brick 5, 3, 7, 3, 9, 3, 11, 3. So at 5, 7, 9, and 11, we have bricks. We have questions at 6, 3, 8, 3, and 10, 3. So that's 6, 3, 8, 3, and 10, 3. And so on and so forth, okay? And if you look over here, where I said tile pipe, where's my pipe? So my pipe tall is at 15, 0. And if I go over here and I actually look at my grid and I turn off the textures, turn off the grid, oh, I want to turn on the textures. There we go. So this pipe actually extends all the way down here. So that pipe is a little bit taller. And if you just want to see what happens, so if I change this pipe tall from 15.0 to 15.2, then what happens when I run it is that now the bottom left corner of the pipe is aligned with the bottom left corner of 15.2. So this is the actual height of this pipe, but I specified it below the ground tiles. Now, something that is missing in SFML is the ability to specify exactly like a layering system. So in our game right now, all we have is that whatever gets drawn next gets drawn on top of whatever was there before. So the reason I display the pipe before I display, the ground tile is because if I didn't, for example, if I take the ground tiles and move them before the drawing of the pipe, then the pipe will overlap the ground tiles. Okay, so just keep in mind that when you're making your own level file. So let's undo that. So now it should be correct. All right. And at the very bottom, after all these tiles, so this is a pretty long level, you have, you can also specify like half tiles if you want to. And the reason for that is because sometimes the size of the animation doesn't line up perfectly with the size of the grid. So these are floating point numbers that you can read in. And also, at the bottom is the player specification. Alrighty. So let's look at the exact specification of the tiles. So the tile entity specification in the level is going to be tile n gx gy. So n is the name of the tile, the animation that's going to be played for that tile, right? So let's just have a look at that once more. So if I go back to the level file, whenever I say tile n, so here n is ground, that means that in my assets file, there has to be an animation called ground. And if there's not, when I go to run my program, it will crash. Okay, and it's fine. You don't have to do that sort of error handling. But there has to be an animation defined with that name in order for me to use it in my level file. And then the GX and the GY are the grid X and Y position. Now, I could have just put these in here as pixel X and Y locations, but trust me, when you go to make your level, you'll be very happy that I used this grid system and didn't have you have to multiply everything by 64 and shift it down left by 32 and all that kind of stuff. It's just nonsense. All right. The decoration entity specification is exactly the same, so it's just dec name X, Y, but if I specify something as dec, then we don't interact with it, okay? So let me just show you an example of that by taking the first tile and specifying it as dec. And what you could do with this is now you have like hidden traps in the floor and stuff, okay? So that's how you can use dec if you want to implement that sort of game mechanic. And you get that for free just by having this really cool system that we have. Okay, so let me change that back to tile. The player specification is just a little bit more complicated, but we basically had the same thing in assignment 2. So player, we have X, Y. So that X, Y, that should actually be GX, GY. So this is the grid. So this is the grid pos. This is the X and Y position. So this is starting position of player. So for example, here in the file, we have the player starting at position 2, 6, and that's the grid position. So whenever the level starts, Mega Man starts at 2, 6 and then falls down, okay? So if I go to the grid, 2, 6 is right here where my mouse is, and if I restart it, that's where Mega Man starts, and then gravity takes over and makes him fall down. 4848, that is the bounding box width and height. And again, we specify that because the bounding box size is not always going to be the same size as the animation. We have the left and right speed. This is speed X, okay? So whenever Mega Man runs left or right, that is just the speed you set. So it's a pretty easy calculation. The jump speed is next at SY, and that is the vertical speed that you give Mega Man when you hit the jump button and jumping is legal. So jumping in this game is remarkably simple because what happens is all you have to do is give Mega Man a negative Y velocity to start him traveling upwards. And what happens is when Mega Man starts traveling upwards, you don't need to worry about what the jump height is or any logic because gravity will be applied to Mega Man and eventually pull him back down to Earth. So if my initial upward velocity is say 20 frames per second, but my gravity is 1 frame, if my upward velocity initially is 20 pixels per frame, that's what I wanted to say, 20 pixels per frame, and my gravity, for example, is 1 pixel per frame downward, then on the second frame, the upward velocity will be 19, then 18, then 17, then 16, and eventually after like half a second, as you can see, Mega Man will be moving downward because now his Y velocity will be in the downward direction all the way till he hits a tile and stands on the tile. Cool. The max speed is given by SM, and that's just if you ever detect that Mega Man is moving faster than that, you cap his speed in that direction by that amount. Then you have gravity, which is GY, And here gravity is equal to 0.75. So what that means is that every frame, Mega Man's y velocity has 0.75 added to it. And again, because SFML uses 0, 0 as the top left, y increases downward. And so our acceleration due to gravity is going to be a positive value, rather than in real life, it's negative 9.8 meters per second squared. In our world, we're flipped on our head, okay? And then the last thing is the bullet animation. So this is really cool too. So Buster is one of the animations, and if you've ever played Mega Man, the Buster is this thing. So what I can do is I can actually just go in here and say, let's give this a brick animation. And now what happens when I restart the game and load the level, now I'm shooting bricks, right? And you saw one get destroyed there because it's interacting with the ground. But yeah, I can change what I'm shooting just by changing that. Someone said in the chat, can't wait to be shooting pipes. Well, let's try that. Pipe tall. Let's see what happens. Pipe tall. We'll go in here. We'll get to a bit of a safe spot, and then we'll shoot some pipes. Okay. Can't wait to be shooting Mega Mans. Actually, yeah, let's look at that. Let's see what happens when we shoot the run animation. So if we did it correctly, we're shooting running Mega Man. But do you see how powerful ECS is now? Right? That's crazy how easy this is. So that's really cool. Okie dokie. So let's change this back to Buster. So that's the level file. Super, super easy. All right. So here's some hints. And I'm going to go through these hints, and then I'm going to go through the code of the assignment so you know where to do stuff. So this assignment has a lot of stuff in it, so I strongly recommend doing things strictly in this order, unless you are super confident, okay? So here's one thing that wasn't super obvious to me. There's something called the curse of knowledge. And the curse of knowledge is sort of a logical fallacy, in which once you know something, you assume that it's obvious to everyone else, right? Because how could someone not know this? If I know it, then how could everyone not know this? But there was a point at which you didn't know it, right? Someone had a quick question, is there no window configuration file? No, in this assignment, there's a fixed window size, and that has to do with the grid system. So you know how to change window sizes at this point, so it's no longer interesting. So it's a fixed window size. But yeah, back to the curse of knowledge. One thing that is kind of difficult. Now, you guys are fourth year, so it's not so bad. But in like second and third year courses, especially in like my third year course, assignment 2, what some people did, and this is not me making fun of anyone, it's just a lack of experience, is that you have an assignment which might take, let's say, 200 lines of code and 10 different functions. And so what some people do at the start of their programming career is they will write all 200 lines of code, and then they'll run their program for the very first time. And if you do that, you have absolutely no idea where your code is breaking. If you can somehow get it to compile, right, what you should probably be doing is writing a single function, seeing if it compiles, and then testing its functionality somehow. Then write another single function, see if it compiles, test its functionality somehow. So make sure you're doing that with this assignment, okay? If I come back here, I'll show you what I've given you in the assignment to start off with, and I've just given you this. So when you run the assignment, I've given you some sample code about how to set up an entity, how to use the animation, and how to draw stuff to the screen. But that's it. So you have to work from... The only thing you're really given in this assignment is the rendering system. Okay, so let's look at the hints. So I recommend you approaching this assignment in the following order, which will help you debug your program along the way with minimal errors. Remember to do one step at a time and test whether what you have just implemented is working properly before moving on to any additional steps. So first, the rendering system has already been set up for you. So if you run the program straight from the start, it's already rendering stuff. You just have to put it in the right spot. Actually, that's pretty much all of game programming. It's just rendering and putting stuff in the right spot, right? So you can press the R key to toggle, no, this is T, this is C. So you press T to toggle the drawing of textures, C toggles the drawing of bounding boxes, and G toggles the grid. You can implement the animation update and animation has ended at any time. It will not affect the gameplay mechanics whatsoever, just the animations. So I'd say leave this until one of the last things. Like, animations don't really affect the gameplay or the physics, so don't worry about that too much. Implement game state play, or sorry, this is scene play. This is from last year. Implement scene play load level. So, since rendering is already completed, once you correctly read in the different types of entities and add them to the entity manager, they should automatically be drawn to the screen. So since the rendering is done and it takes all the entities from the entity manager, as soon as you're properly inserting them in the correct positions, that should be done for you. Add the correct bounding boxes to tile entities and no bounding boxes to the deck entities. Remember, you can toggle the debug viewing of bounding boxes with the T and the C keys. This is scene play. As part of this step, implement the scene play grid to mid pixel function, and I'll show you that in a second, which takes in as a parameter a grid XY position and an entity and returns the vec2 position of the center of that entity. You must use the animation size of the entity where its center point should be. Keep in mind that this means that your entity must have its animation component added first before the transform component, so that it can be used to calculate the midpoint in this function. Okay, so what the hell does that mean? Let's look over at our GameStatePlay class, because this is where you're going to be putting most of your code. So in the init function, I've done some things for you already. Let's just go from the top to the bottom. So the constructor is done for you. The constructor calls the init function. The init function is basically going to set up your screen. It also takes in a level path. It's going to register all the actions. And right now, none of the movement actions are registered for you. So last time we talked about this system and how we do registering of actions. So you will probably have to do something like this, where you register action, and then you take SF keyboard, for example, A, and this is going to be left. So you're going to have to register the movement actions, because right now the only things that are registered are the following actions. Okay, and we'll get to the do action function and how you interact with that. Then I just set up some, I set up the text for the grid, so don't modify this, that's there. And then this calls load level with the level path. So load level down here, this next function, is going to be what you implement to properly read in all the entities from the level file and give them their correct positions. So let's look at that one. We reset the entity manager every time we load a level. So whenever we load a new level, we just reconstruct the entity manager and that will clean it all up for us. Then what do you have to do? You read in the level file and add the appropriate entities. Use the player config struct mPlayerConfig to store the player properties. This struct is defined at the top of sceneplay.h. Note, all of the code below is sample code, which shows you how to set up and use entities with the new syntax. It should be removed. So I showed this already in the last class, the new syntax, but I want to show it again. So what we're going to do here, just for demonstration, is we're going to spawn a player. Okay, so that player will be spawned. I'll show you that function in a minute. So let's put in some sample entities. So let's put in a brick entity. So if we run this, we can see that we have we have a player in the scene, we have a brick, we have a block, and we have a question. Okay? So let's add a brick. So we say auto brick equals entity manager.add entity tile. That will give us a shared pointer to an entity called brick. The first thing we want to do, it's really important in this assignment that we always add the animation component first, because what we have to do here is we're going to be reading in the grid X and Y location and converting that to the coordinates of the middle of the entity in pixel coordinates. So that's very, very important. So in order to add an animation, what we do is, as we said last time, the assets live in the game engine object. So if we look over in the game engine object, so this is the game engine class. It contains the window. Okay, this is part of the new architecture, which we already talked about. It contains the assets class. It contains the current scene and the scene map and all this kind of stuff. And I'll go over this a little bit later, but this is where we get the assets. So in the game engine class, we can call assets to return the assets for us. So over in scene play, I can say mGame, because in our scene class, whenever we construct a scene, we pass in a pointer to the game engine object. So we can always access the game engine object that contains this scene. Scenes also contain the entity manager and the action map, but we talked about that last time. So we can say, hey, game engine, give me your assets and get me the animation brick. And true here means that this is a looping animation. So even if it's a static texture, it's just a looping animation with one frame. So that's how we add an animation to our entity. Next, we're going to add a transform to our entity, and this is going to be the position of that entity. And here is when you want to call, so what you'll actually do in your assignment is when you read in grid X and grid Y, and you have your brick entity, you're going to, as your position of your entity is going, you're going to call the grid to mid pixel function, which is up here. So this is an important function, and you'll call this on every entity that you read in from the level file. So this function takes in a grid XY position and an entity. You're going to return a vec2 indicating where the center position of the entity should be. You must use the entity's animation size to position it correctly. The size of the grid width and height is stored in mgridsize.x and gridsize.y, and I'll add one more thing. The bottom left corner of the animation should align with the bottom left of the grid cell. So that means, again, that, for example, here I've specified this bush big entity. The bottom left of this entity should align with the bottom left of the grid cell that it was defined in the level file. So this bush big entity was given 0, 1, so the bottom left has to align with 0, 1. So what you're given here, for example, is bush big 0, 1. So you pass in 0, 1 for X and Y into grid to mid pixel, and this entity has the bush big animation on it. So you look up the size of the animation, and you do the math that will return the middle pixel of where this bush big should be drawn. Okay, so that's the most confusing part of the assignment, in my opinion. Okay. Now, let's say that you want to do some logic in your collision that says, hey, is the thing that I'm touching a brick? Is it a question mark? Well, what you can do is you can use this syntax. So you can get the animation component of the tile, and you get the animation object of that component, and then you call the getName function. And if that's equal to brick, then you know it's a brick. Okay, so you can use that throughout the assignment. Next, let's add another tile. So our block, we can say auto block equals mEntityManager.addEntityTile. We give it the animation of block. This is, again, a repeating animation. We give it a transform component so it'll draw somewhere on the screen. And we can add a bounding box, and that bounding box will show up if we press the C key. So let's just do that. So if I go into our what I give you initially, if I press the C key here, then only the player and the block have been given bounding boxes, right? And so these are the only ones that show up when we toggle off the textures. And the reason for that is because here I have added a bounding box to that tile. Up here, I did not add a bounding box to the tile, and so it doesn't show up whenever we do the debug stuff. Next, we're going to add the question mark component, and that's the exact same thing. No bounding box, so it doesn't show up. This is incredibly important. This is a little bit different from the last time, so you have to be very, very important. You have to pay close attention to this. Components are now returned as references rather than pointers. Hence, if you do not specify a reference variable type, it will copy the component rather than point to it. So what I mean is, over here in entity, whenever we say get component, we are returning a reference to a component. So what does this mean? So this line of code will copy the transform into the variable transform1. It is incorrect. Any changes you make to transform1 will not be changed inside the entity. So if you want to set up temporary variables to transforms, which is often, like, for example, if I want to say, if I want to get the transform of this question block, I could say auto transform equals question get component C transform. And the reason I might want to do that is because down here, maybe I want to do a bunch of things with the transform on multiple lines, but I don't want to always have to type this out, right? So down here, if I say transform.x equals, or transform.pos.x equals 10, then this will actually set the transform component's x variable to 10, because this is a reference. But if I delete this reference here, then I've actually copied the transform component into this local variable, which then gets modified, but the actual transform of the entity does not get modified. So just a very important note, if you are creating temporary variables to point to these components, then you have to have a reference here. So that's what this is talking about. So it says this will properly reference it. We have our reference there. Okay. Spawn player. Here is a sample player entity that can be used to construct other entities. So we say mPlayer equals mEntityManager.addEntityPlayer. We can add our animation component. Then we can add it to the level, or give it a transform, and give it a bounding box. But of course, there's other things that we need to add here as well. All right. Spawn bullet. This is another function, and this function is what you're going to be using to shoot bullets, so similar to assignment 2, and bullets are going to come out of the entity and go left or right based on what direction that entity is facing. The update function of the scene, you have to correctly fix this so that pausing works correctly. The movement function is where a lot of your logic is going to be. So you have to implement the player movement and jumping based on the C input component. You have to implement gravity's effect on the player. You have to implement the capping of the maximum speed on the player. And also, just as note, setting the entity's scale x to -1 or 1 will make it face left or right. So if we go over here to components, now the C transform component has a scale, and just by setting this scale's x value, this will have Mega Man facing right, and this will have Mega Man facing left. So that's how you do that. Okay, lifespan. This is similar to assignment 2, so I don't need to explain that. That's where you calculate the lifespan. You can pretty much copy and paste assignment 2's code here. Now, the collision system is where all of your headaches are going to be. So, first, just remember, SFML's 0, position is in the top left corner. This means that jumping will have a negative y component, and gravity will have a positive y component. Also, something below something else will have a y value greater than it, and something above something else will have a y value less than it. So here you have to implement the physics getOverlap function. Okay, so we looked at getOverlap in the notes. That was from our rectangle collisions. So if we go over to physics here, physics.cpp, here we have a getOverlap function between one entity and another entity. So you take entity A, you take entity B, you look up their bounding boxes, and you return the amount of overlap between them given the formula that we used in the assignment. And that's based on the position and the bounding box. There's also a getPreviousOverlap function, which takes in an entity A and an entity B. And now what we're doing is inside our transform component, we also keep track of the previous position of an entity. And so whenever you update the position of an entity, what you have to do is properly update it. But before you do that, you set its previous position to its current position. All right? So that's how we can do things like knowing if it came from the left or from the right or from above. And we talked about that a couple of classes ago. So you have to implement that getOverlap function, and you have to use the getOverlap function here in your collision. So we're making sure that you do it the way we want you to do it. You have to implement the bullet and tile collisions. And so you destroy a tile if it has a brick animation where, so if a bullet collides with a tile, it kills the bullet. But if the tile was also a brick animation, then you kill the tile as well. You implement the tile and player collisions and their resolutions here. And you also update the CState component of the player to store whether it is currently on the ground or in the air. This will be used by the animation system. So if we look, each player has each entity has a state component. So really you're only going to be attaching this to the player. So in this state component, whenever you detect that you've jumped or you've hit something or you're on the ground, you can set the state of a player. So for example, when I start the level, Mega Man is falling. And so what you should probably do is just assume all the time that Mega Man is in the air. And then if you detect on that frame that he has collided with something, now he's on the ground. So you set this state component, and then your animation system will read the state component to see what state Mega Man is in and set the animation correctly. Okie dokie. Also, check to see if the player has fallen down a hole. So this is y greater than height. And also, don't let the player walk off the left side of the map. What does that mean? Well, here, I can't walk off the left side of the map. Okay? Okie dokie. Here is the doAction function. So right now, I've given you the syntax for this. And what you have to do is you have to add or register your actions for the playing of the game. And then down here, whatever you've called those actions, you have to call it inside the doAction function. So for example, I might have if action.name equals left, then I take my player's input component and set it equal to left, right? So you did something like that for assignment 2, but you did it inside the input handler. Next, you have the animation system. So you first have to complete the animation code before you do this. Then you set the animation of the player based on its CState component. And then for each entity with an animation, call the animation's update function. If the animation is not repeating and it is ended, destroy the entity. So that's where that happens here in the animation. You also have to implement the onEnd function of scene play. And what that means is when I hit the escape key, if you look up here, so the escape key is the quit action. And when the quit action happens, I call onEnd. So whatever has to happen here in onEnd, when I hit the escape key, it has to quit the scene and go back to the menu state. And the way you do that is, so inside scene, there's a has ended Boolean. So you have to set that to true. And then in the game engine, there's a function in game engine, which is change scene. Okay. So change scene takes in a couple of parameters. It takes in the name of a scene, it takes in a shared pointer to a scene, and it changes the current scene, or whether or not you want to end the current scene. So let's talk about that for 1 second. So the change scene function is written for you. I just want to go over it for a second. So again, there's 3 variables here. There's the scene name, the scene itself, and the current scene. So what it says is, first, if we've passed in a scene, so if this variable is not null, then take the scene name and set the scene map's value of that key equal to the scene, all right? So if we've passed in a scene name, let's say we pass in the scene name menu, right? And we pass in a scene variable here, so an actual shared pointer to a scene, then it will set that up in the menu. So let's look at an example of this. So in the game engine, we first call the following. So this is how the menu scene gets added. We say change scene to menu, that's the string, and then we set up a shared pointer to a menu scene with this, which is the game engine, as the parameter. If we go over to the menu scene, in our do action function, whenever we hit play, what we do is we change the scene to play, and then we put in the following. So this is a shared pointer to the scene play, which takes in a pointer to the game engine as a variable, and it also takes in the currently selected menu text as the level that we want to load. So over here, what you have to do is you have to say mGame change scene, and this is probably going to be, well, you want to go back to the menu. Well, there's a menu scene, and do we want to create a new menu, or do we want to use the existing menu? So in the game engine, again, in the change scene function, if scene is equal to null, if scene is not equal to null, then we have passed in something. Otherwise, if it is equal to null, then it will just set the scene to the thing in the map which already has that name. So since there's already a scene in the map with the name menu, here we can just say, I'm just going to change the scene to null. And do I want to destruct the current scene? Yes. So that's the syntax for this here. So whenever you want to change a scene, it's the name of the scene you want to change to, whether or not you have a new scene set up, or you want to use the existing scene, or, and whether or not you want to destruct the current scene. So that's just our state machine that we set up before. And here we have a drawline function. This is just a helper function because SFML doesn't come with a drawline, and I've implemented the entire rendering system for you. But if you're going to implement some new features, it might be that you have to change that, okay? The one extra thing that I want you to try and understand, but not change, is the following. So we haven't talked about this yet because we're going to have an entire lecture devoted to this for assignment 4. But if you notice, when I'm over here, the camera isn't changing. But as I run to the right, if Mega Man's position is greater than the middle of the screen, then I'm actually following Mega Man with the camera. And that uses SFML's view system, which I want to be present in this assignment, but we haven't learned about it yet. But we will learn about that in a couple of lectures. But as I said before, that's all done for you. So if you want to look at that code, that's how you do that here, okay? All right, and the components that are available in this assignment, we have the transform component. So we have the position, that's the current position of the entity, the previous position of the entity on the last frame, so make sure you update that, the scale of the entity. So if you change this to like 2 and 3, then when you draw the entity will be 2 times larger in the X direction and 3 times larger in the Y direction. So you might use that to some special effects if you want to. We have the velocity, of course, and we have the angle. There's 3 constructors here on the transform. So if you want to construct a transform all at once with all the variables, you can do that. Again, we have the same lifespan component that we used and the same input component that we used for assignment 2, except now we have a canJump variable. So you can use the canJump variable of the player's input component to store whether or not you can jump. So for example, if you're in the air, you can't jump. If you've landed on the ground and you've let go of the button, then you can jump again, etc. So you have to do a little bit of logic associated with that. Here's the bounding box. And again, remember, we're storing the half size for the bounding box. So we're storing the size and the half size. And the reason for storing the half size we talked about in the collision lecture. We have the animation component. So the animation component stores the animation object itself and whether or not it's a repeating animation. We have the gravity component. By default is 0, but you can set up the gravity component as well. And lastly, we have the state component, and the state by default is jumping, and you have to set that. Okay? And I believe that's it, but I want to go through, again, so now that you know what the functions are, here's the order in which you should do that. So first, implement load level, because once you've loaded in the level, everything will work for you. Like, not everything, sorry, the drawing of the entire level will work for you once that's done. Here, then you want to implement the scene spawn player function. So you want to read in the configuration file for the player and spawn the player. Okay, and this is where the player should restart when they die. Then what I want you to do is just implement some basic WASD up, left, down, right movement for the player entity so that you can use this to help test the collisions in the future. Remember that you must use the register action function to register new actions for the scene. See the actions already registered for you for the syntax and the do action function. So what I mean by that is instead of immediately trying to get things to work with gravity and jumping and everything, just make it so that if you press up, the player goes up. If you press left, the player goes left. If you press right, the player goes right. If you press down, the player goes down. So give it the same controls as assignment 2, because what that will do is it'll allow you to like go all over the map and approach entities from the sides and debug all your collisions later. So leave gravity until after your collisions are working. Then implement the spawn bullet function. So bullets should shoot when space is pressed in the same direction player facing. Holding down the space button should not continuously fire bullets. A new bullet can only be fired after the space key has been released. Use the canShoot variable to implement that. Then you implement the getOverlap function. So this function should return the overlap dimensions between the bounding boxes of two entities. This is the same as the purple rectangle in the notes. GetPreviousOverlap should be a copy and paste of this function, except using the previous positions instead of the current positions of the entity. I'm going to add one thing here. If either input entity has no bounding box, then return vec2 0, 0. Okay, so you check to see if they both have bounding boxes first. Implementing collision checks with bullets and bricks and tiles such that the brick is destroyed when a bullet collides with it. Remember, a collision occurs when the overlap is non-zero in both the X and the Y component. Bullets should always be destroyed when they collide with a non-decorative tile. Then you should implement collision resolution such that when the player collides with a non-decorative tile, the player cannot enter it or overlap it. And we talked about how to sort of push you back out from that. When the player collides with a tile from below, its Y velocity should be set to 0 so that it falls back downward and doesn't hover below the tile. You should implement a way of detecting which side the player has collided with the tile, because you need to know, question in bricks, whether you've collided from above or below. And then change the controls so that they are the proper left-right jump style controls. All movement logic should be in the movement system. The do action system is only used to set the proper C input variables. If you modify the player's speed or position anywhere inside the do action system, you will lose marks, as this is potentially unsafe and produces unwanted effects. And then you implement the gravity such that the player falls toward the bottom of the screen and lands on tiles when it collides with them from above. Note that when the player lands on a tile from above, you should set its vertical speed to 0 so that gravity does not continue to accelerate the player downward. So here's what's happening in the background here. And let me go back to the blackboard for a second. So something that's really interesting that may not be obvious is that let's say you have some ledge that your player is currently on. And then you have your player. And so these are the bounding boxes, right? So what's happening is you're falling. You're falling. You're falling. So you're over here, you're falling, 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 falling. And then on some frame, you've fallen into this, right? You've fallen into the bounding box. So what you want to do in your code is you detect that this came from above, and you want to push this guy back up so that it's just on top of this tile, right? Now, every frame, gravity is still pulling this thing down. So it might go here and then down a little bit, and then you push it back up. But then gravity is decreasing the speed even more. So you go down further than before, then you push it back up. Then you go down further than before and push it back up, then further than before. And so it's decelerating the whole time, right? And then at some point, your gravity may make your speed so far downward that you just pass through the tile. And if you've ever watched like Super Mario 64 and use like backwards long jumps and stuff like that, essentially they forgot to cap the backwards movement speed. And so you definitely want to be capping speeds like this. Not only that, but whenever you hit a tile like this, you also want to set the current Y velocity to 0 so that you have absolutely no chance of this ever happening. Okay, so that's what I was talking about when I meant that. And we are at the end of assignment 3 description. Cool. It is fun to break games, but it's also fun to program games so they're not super breakable. So remember that you have to make your own level. I want it to be at least a few screens long. I want it to be such that it shows off interesting gameplay mechanics. And especially if you've done any bonus stuff, I want your bonus stuff to be incorporated into the level that you make, okay? So when you go to make a level, make sure to hit the G key so that you can see the grid and you can really easily place all your stuff. Cool. And again, you have 21 days to finish this assignment. So let me go back. So it's being given out today on the 20th. It's going to be due on November 11th, but trust me, there is a solid 2 weeks of work in this assignment. You just saw it took me an hour and a half to explain what you have to do without you having even done anything, okay? And you're going to struggle a little bit with those collisions. Trust me, there's like off by one errors and whether it's below or above, etc. And if you do not have a partner for this assignment, get a partner because it's going to be a lot of work. And I will be posting that assignment just around midnight tonight so that it doesn't overlap with this assignment, which is due at midnight tonight. Cool. So after that, we're going to go into a bunch of other cool stuff for assignment 4, and we're going to have a good time going forward. Also, at some point in the next 2 weeks, I'm going to be giving part of a lecture on what your project is going to be, okay? And essentially the project is going to be you have to include everything that we've learned in the course. Make your own levels, get your own assets, and make a huge game. So that's going to be fun. So that's assignment 3. I hope you have fun, as much fun programming it as I had making it. And you can't use the solution from previous years if you happen to find them from other students because it's almost completely different. So there you go. All right. So there's no questions out there. So I'm going to end it there and have fun with assignment 3.